Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, this is Amy Lewis, and we're here for another exciting episode of Engineers Unplugged. We've got Vaughn and Mike, and we're talking about software-defined storage. All right, well, fine, I'll get out of here. Vaughn, you take it away.
Thanks, Amy. Mike, big trend occurring in the data centers, this construct of a software-defined data center, customers looking to accelerate their delivery of IT resources through end-user portals to drive more agility into their data center operations. This big goal of a software-defined data center means all the IT resources have to be virtualized. That includes storage. So let's start talking about software-defined storage.
So I wanted to start off talking about software-defined storage in the context of someone who would be a common user of storage, like say an application owner. So I should have taken the cap off earlier. So I've got an application, we'll say it's SQL, and it's almost certainly encapsulated in a VM. And it consumes storage, so it's talking to a storage array. Now, from the virtual machine level, I'm expecting to get things like agility and the ability to draw from a large pool of clustered compute resources. But if I look at the storage layer, the storage has capabilities like it can do SAN, it can do NAS, and it's got characteristics like performance, thank you, and it's got capacity. But these constructs are all tied to an individual piece of hardware. So this is a very rigid architectural model. And if I want to have the kind of flexibility that I get from my virtual compute layer at the storage layer, how would I go about doing that?
So thanks for the setup. So this is the perfect introduction so that those can understand the challenges within storage. If I were to clean up our board here a bit, and I want to eliminate this rigidity, I think the ideal goal is to move away from a storage device that's physical in nature and introduce some layer of virtualization and abstraction where we are abstracting storage resources from pools of hardware that are underneath and turning this storage device into a virtual device like a storage virtual machine as a concept. Now, to be clear, Mike and I, besides writing the book Virtualization Changes Everything, which is a great storage introduction to those in the cloud infrastructure, we both work for NetApp. We want to make sure that this is a very kind of unbiased presentation. So this abstraction layer for a NetApp customer would be cluster data on tap. It's the storage platform in a FlexPod, but this could be delivered in very similar means through other vendors like EMC's Viper, just to name one off the top of my head. So through this abstraction layer, I now have a software-defined storage controller. And I still have the same level of storage services, be it SAN or NAS, be it capacity and IOPS, but also have means like data protection and replication. I can go through different performance tiers based on software-enforced quality of service mechanisms, right? I gain a significant amount of agility. The end result here is I'm separating the data access from the underlying hardware so that as my application lifecycle or my application goes through its life cycle, I should say, I can assign the appropriate resources in order to meet and align to the needs of the business.
Now, of course, all of this still does have to run on hardware, but because we've separated the data access layer from the physical resources themselves, we can create pools of resource that are flexible based on the needs of the individual user. So I could use storage controllers from companies like NetApp or EMC. I could use commodity hardware by taking servers with commodity disks inside them and using a VSA to provide access to that resources. Or as these virtual storage constructs start to move out into the cloud, I can start to access resources from cloud service providers and get them that way. The important thing is that for this big pool of physical resources, the access layer and the way that the application and the administrator interacts with the storage resources all remain the same. So I can make changes between this based on capacity needs, performance capabilities, strange deployment like remote field offices, and still maintain the exact same administrative capabilities and the exact same feature set. Now, there is one more thing that we'd like to touch on, which is to bring it back to that original application owner.
Right. So we've talked about abstracting the access point for storage, allowing a pool of storage in various types, be it multi-vendor, cloud, server-based storage, to power this pool. But we started with software-defined data center and driving agility to the app. And this is where it's critical with the technologies that you consider to have open and programmable APIs. And these APIs can come in formats such as direct integration into your management frameworks, be it your infrastructure like UCS Director or OpenStack, Microsoft System Center, or VMware vCloud Suite. This also could be in the forms of your application layer, SQL, Oracle, SAP, as well as your backup interfaces, be it NetBackup or Commvault, some vendor along that lines. But what you want to do is to be able to have an integration point driven by APIs where the storage resources are assigned based on policy and permission for functionality is granted based on RBAC by the storage admin to the virtual machine, and the consumption comes from the application layer down in the storage stack, allowing the business owner of whatever the application may be to be able to respond in a much more timely fashion to changes or the needs of their end customers. Any final thoughts, Mike, as we wrap up?
No, except to say that I think that the important thing about this is that we understand the concept of agility at the compute layer and certainly at the network layer as well, and it is possible to have that same kind of agility at the storage layer.
So that's us, software-defined storage.
Okay, so since you've been on, I know you're a very capable unicorn drawer, so I'm going to spare you this time. I'm going to... Do you think...
8 takes to make
Okay,
a cloud.
all right, here we go. Oh, you draw the unicorn. I'm going to ask some questions. Okay, so get going. So on a scale of 1 to unicorns, Vaughn, what do you think, where are we in terms of our journey here? I mean, software-defined is such a buzzword in our industry right now, but where, and I know it's going up the stack, where do you think we are here in terms of storage?
So I think software-defined is, let's be honest, it's an emerging market conversation. But strategies that are employed by vendors such as VMware, EMC, and NetApp, we share a very common vision. We're going to diverge when it comes to the execution on that vision based on our product portfolio. But I think if you scale back and say customers want to have greater agility, efficiencies, and choice of deployment models, all of these vendors are providing means for you to consume that capability. So on a scale of, is it 1 to 5 unicorns?
I would say, yeah, 0 to unicorns.
Oh, 0 to unicorns? I think we are at unicorn tail. It's here in various formats. Some vendors shipping, some will be shipping around the end of the year. NetApp Cluster Data on Tap is in the FlexPod, so you can have it today with the FlexPod or our NetApp suite. Sorry for the plug. But this is where you're going to move in your data center towards.
Well, I'm glad you're in the business of storage and not unicorn drawing. That's all I have to say. Because something that customers...
Got a bird's head.
Wow. So good thing these guys are in the engineering and storage business.
Is that a Unisaurus?
Great information. Really appreciate you being on today's episode. Thanks, Mike. Thanks, Vaughn.
Thanks, Amy.
And we'll see you next time on Engineers Unplugged.